New topic. Belting. Ada 3 different type of power transmission system. So this is gear. This is gear. So this one is belt. Another one is chain. So gear contain gear wheel and shaft. Belting, they should have a pulley and belt. Chain, they are the roller chain, and this one is sprocket. So ni just a comparison lah. Yang ni kita tak masuk dalam syllabus kita. So the comparison is gear drive ni dia capable untuk higher torque higher torque punya power transmission, tapi dia tak flexible kan. And then of course dia expensive. And then kalau you refer kepada belting is more flexible, but dia boleh pergi high speed, but then lower torque compared to the roller chain and sprocket, lower speed but with a high torque. This is due to the belting ni, dia boleh occur friction. Belt and pulley, that one. So dia boleh slippage lah. So the less torque will be produced compared to the roller chain and sprocket ni. Dia ada meshing, some sort like macam gear lah. Dia ada mesh between the roller chain and the sprocket itself. This is a typical example of our previous gear system, where in a ball mill they have a outer ring over here with a gear. This is the orange color is only the cover. So they should have another pinion over here, smaller gear, and then connected to this is the gearbox. This is the gearbox, and then this is the electric motor. So this is the system of a gear system lah to rotate the ball mill. But when we compare to the using the belt, so basically this is also a ball mill system, but the power transmission is using belt. Kalau you tengok pada this one, this is actually the electric motor. So electric motor, dia ada shaft kan, and then this is one pulley over here. So this pulley is connected to another pulley over here. So ni dah jadi satu stage lah kan. One stage reduction. I mean the of course kalau untuk this application, motor will come with a higher speed, higher RPM, and then this one probably will lower RPM, normally around 20 to 30 RPM. So this is a reduction belting system lah. So this is one stage. At the same shaft over here, kalau you tengok belakang ni ada satu lagi pulley. So this is another pulley connected with the belt, multiple belt, multiple belt with another pulley over here. So this one consider a second stage. And then at the same shaft over here, they have a small pulley over here. Same thing, there is a multiple belt over here. and then connected to the male body itself. So this is the third stage. So kalau you tengok dia punya comparison in this belting system untuk running ball mill, dia required more space lah, banyak tempat kena pakai kan. So and then kalau tengok pada safety yang ni dia tak ada cover langsung lah. So agak bahaya compare to gear system lah. Tapi gear system tadi dia properly nampak dia ada cover kan. So baguslah dia punya safety dia. Okay, move to the next slide. Our objective sebenarnya kita nak describe after the belt topic. I believe nanti you dapat describe the basic feature of belt, and then describe several types of drive transmission belt, and then solve a few kinematic belt tension and problem of the drive belt system, and then learning topic as mentioned here lah. Okay, in general, if you have a belt system, you should have a driver. This is a pulley. This is a pulley. So this is pulley attached to the shaft. So you should have one driver lah. So ni yang bawah ni. This is the input. So this is from the electric motor lah. And then they should have connected to your output lah. Output to your machine kan. Your machine nak pakai kat mana and so on. Sama ada reduce speed ataupun increase speed. So driver, driven, output, and then idler pulley. Idler pulley ni normally untuk they serve bukan untuk output, but normally they attach to some other shaft, and then tujuan dia sebenarnya untuk push the belt, push the belt supaya dia enough tension to the belt supaya dia tak berlaku slippage. Some other cases dia tak ada idler pulley ni, they just connected between driver and driven, so connected something like this here. So connected something like this, but then dia punya tensioning will be over here lah. So dia akan tarik macam you punya rantai basikal lah. Macam you punya rantai basikal. So something like that lah. So tension will be akan di-apply pada sini. Okay, then this is the explanation lah dia punya apa benda belt ni actually. So idea dia belt ni adalah flexible material lah, it's a loop. Rotate mechanically linked two or more rotating shaft. So nanti you tengoklah. So kalau you tengok yang ni, this is pulley with two groove. G-R-O-O-V-E. Groove tu maksudnya yang dia punya so called longkang lah, groove. So dia ada two groove over here. So belt pun ada dua. So each belt akan duduk pada each groove. So ada belt yang ada pulley yang ada satu groove, dua groove, tiga and so on lah. It depends on the torque yang dia nak transfer to the another shaft lah. Untuk this case, untuk gambar ni, ini adalah pulley with two groove untuk letak dua belt lah. It's a V belt actually. This is a V belt. Okay, so far?
Okay, Doktor.
Okay, Doktor.
Okay, right. Next slide. Next slide is a comparison between gears and belting. Kalau you tengok dia punya velocity ni, velocity at P compare to the belt over here. Kalau you tengok you punya basikal tu, bila you kayuh, dia ada satu kawasan rantai yang in a tight side, dia tegang kan. So yang sebelah bawah dia akan jadi kendur sikit kan. that one is on the slack side. So bila ada creep ni, berlaku creep ni, dia berlaku dalam in the belt made of rubber, so dia berlaku elongation and contraction. Elongation and contraction. So, bila berlaku benda tu, dia punya velocity at each point over here, at each point, sepatutnya velocity at each point adalah sama kan. Tapi since dia ada creep belt, so V ni dia V2 ni lebih kecil berbanding dengan V yang untuk R1 lah. So later nanti kita akan tengok. Kalau tak ada creep, yes. If there is no creep, then we can apply this one. Same application lah. You can refer to the free body diagram over here. It means that kalau you compare with the gear over here, gear they mainly is based on the connection, I mean meshing of the gear tooth. But now in the belt, kalau you nak cari dia punya top, you dah tahu tadi one of tension, another side of belt dia akan kendor on the slack side kan. So you tahu torque is equal to force kali dengan R. Force mean the tension of the belt itself. Here, tension of the belt is actually the resultant of the tension. Resultant tension, meaning you got the higher tension on the tight side, and then minus the tension on the slack side. Then only you get the resultant tension. You darabkan dengan the punya radius of the pulley, then only you can get the top of the belt system. At which point? At pulley, which pulley lah? Okay. That is the thing lah on the top. And then power you can still refer over here. And then later kita akan ada power is equal to TV, if I'm not mistaken. Power is equal to TV, torque times the velocity of the at certain point. Okay, T or FB, or is it tension, FB, the tension of torque, power equal to FB, tension of the belt. Application of synchronized belt drive. Ni kalau dekat engine lah. Maksudnya one belt is connected all the way round to serve multiple application. Either the belt want to operate the alternator, and then probably the fan system, and then probably the water pump over here. So one belt can connect to water pump, alternator, camshaft, and probably the crankshaft and some other thing lah. So it means that is the synchronized belt drive. So keburukan dia adalah bila satu putus, then sistem semua tak boleh jalan lah. Right. This is the application of continuous variable transmission, CVT kan. Yang menunjukkan berkenaan dengan continuous variable transmission ni. Kalau you alert dekat you punya kereta sekarang nowadays, banyak yang CVT, where when we drive, and then it's automatic cars. When you drive the car and then you accelerate from 0 to 100, let's say, you won't feel the gear change from gear 1 to gear 2 to gear 3 because of this continuous variable transmission. They're very smooth compared to the previous automatic system. still in automatic cars, tapi dalam automatic punya transmission. So by the time it change from gear 1 to gear 2, at least you can feel the jerk, the changing from gear 1 to gear 2, 2 to 3 and so on. Compared to CVT, you tak boleh rasa lah, they're quite smooth. Okay, this is a flat belt application untuk I'm not sure this is a motorbike or motorcycle or basikal. Okay, anyway, kalau kita refer pada yang ni, this is probably apa yang dia nak adalah torque lah, dia nak torque ni. Sebab this one could be in dia akan jadi lower speed kan. Sampai sini dia akan jadi lower speed. So nak speed. That is the application lah. Ni contoh je Okay. Why this is what selection of bed drive. Okay, this selection of bed driving is depends on the tadi saya dah cakap space available and then the service condition. Service condition ni kalau you tengok sebagai contoh lah, in that area, in that particular area you nak pasang machine tu, so all the surrounding is very hot. Ada burners, ada apa kawasan yang panas lah, yang tak suitable untuk pasang belting system. So then you need to install gearing system, let's say, at the furnace area and so on. And then speed reduction. Speed reduction ni untuk gear, untuk belting ni pun ada dia punya limitation lah untuk speed reduction. And then ada space available. Space available dia pun tahu kalau pakai gear ni dia boleh jimat ruang kan. Kalau belting of course dia akan memakan ruang yang banyak lah. Others is power to be transmitted. Less power can be transmitted using belt drive. And then center distance between shaft ni maksudnya in between pulley to pulley tu depends lah. You nak pakai, kalau nak pakai gear and then terlalu besar kan. So kalau terlalu panjang then you need to pakai belting. Okay. Others you explore lah nanti. So this is a theory only. Advantage gear system nak kena lay, nak kena buat machining, so of course akan jadi mahal. Belting you cuma perlu satu belt and pulleys and you boleh install, so less expensive lah flexible, smoothly operate, less noise. Can design to sleep when an overload occurs. So dia macam circuit breaker juga ni. Dia jadi circuit breaker, like say dia nak tripkan the belt kalau overtorque kalau overtorque dia akan berlaku sleep, and then ataupun belt to breakages, so in case of overload, so belt tu tak boleh jalan lah. Kalau motor, kalau load terlalu berat, so sistem tu tak boleh gerak. So probably we can design it to sleep when overload is occur. Tapi biasanya when there is the load is within the specification, and then the tightness of the belt pun within specification, it shouldn't happen lah the slip. And then required no lubrication. Can be more than one plane. Betul, can be more than one plane. Maksudnya dia punya arrangement of the shaft and pulley boleh multiple plane lah. You boleh adjust dia punya output and input. Gear pun boleh kan, cuma complicated sikit lah. Easy assemble. Where is vibration? I don't see. Okay. Do well in absorbing shock loading. Kalau you tengok pulley and belt so let's say this is the input the input of motor, dia ada motor, so ada pulley. So let's say this motor is vibrate, and then the another shaft is connected using belt. So whatever vibrate at point A won't be transmitted to point B by having this belt. By having this belt. Compared to the gear, kalau let's say this first gear vibrate, of course dia akan transmit to the gear B. Tapi kalau this one is within the same floor, it still vibrate lah. It still vibrate moving towards the floor. But anyway, since this is rubber, so less vibration will be transferred to the another one. Okay. What we will focus in this study is only on the flat belt and V belt. Flat belt and V belt. This is also a V belt, but a combination of it's a multi V belt lah. Dia cantumkan di sini lah. This is a cork belt. Cork belt ni pun sebenarnya V belt, tapi cuma dia design to be, they have another curve over here supaya belt tu jadi lebih flexible, lebih flexible, can properly sit at the pulley groove. Timing belt normally untuk precise punya movement, precise punya movement. Sebab dekat dia punya pulley pun ada so called macam gear kan, so it need to be precise movement lah. Right. Okay, V-belt terminology. Kalau you beli mesin yang baru, a brand new machine, you will find that this is the pulley, and then this is your rubber belt or any kind of belt, rubber belt. This is pulley. In a brand new machine, you will find that they will have a gap. They will have a gap over here. So the belt is sitting on top. They will have a gap between the pulley to the top. So by the time when the pulley is in operation after several years or several hours or several years, hours kejap sangat kan. So the surface over here, either the pulley or the belt will start to worn off kan. They start to worn off kan. So the belt will sinking down. Dia akan termasuk ke dalam ni lah. And then dia akan jadi flat atas ni nanti. Kalau dah terlampau haus ataupun dah worn off, very bad worn off, you akan dapat tengok nanti dia punya belt tu dah tenggelam. Belt tu dah fully submerged into the groove. Bila dah berlaku keadaan ni, maksudnya this is no good lah. You punya pulley dah wear, you punya belt pun dah wear. So the ideal condition is belt to sit, dia ada gap a bit on top. Okay. Right, this is what? Okay, this is just to explain there is a few type of belt in the market, which is normally we call it type A, type B, and type C. Type A is smaller one, and then compared to C lah. And then they also have D, E, and so on lah. So bigger size, bigger size for different application. Okay, next one. How to calculate the belt length? Taking an example, let's say this is a diameter of belt, diameter of belt is R, radius is R, and then same radius over here. Of course, the belt length you nak measure, mesti you ambil half of the circumference over here plus the another one over here kan. Kalau dia sama size lah. and then you plus the center to center distance. Center to center distance. So dapatlah 2C plus the perimeter of the pulley over here. So that is the belt length on the same diameter pulley. Okay. Kalau pulley yang berbeza, this is smaller size, this is bigger size, bigger size. So what you need, what you have is this formula lah. 2C, same thing again, plus the perimeter of R1 and R2. Okay. And then you need to plus another formula over here. Let's say this is R1, this is R2. So if you look into top left over here, beta 1, and then this one, this is angle beta 2. This one is actually, we call it angle of contact. Okay? Angle of contact, this one. Or angle of lap. Maksudnya belt yang bersentuh pada permukaan pulley. Okay? Ada certain buku, dia ini adalah theta. Ini adalah theta 2. Ini adalah theta 1. So doesn't matter as long as you understand what is angle of contact. Sebab later kita akan jumpa lagi a few symbol yang ada buku cakap lain, and then dalam slide saya lain. As long as you faham where to apply those parameter, then it should be okay. Okay, back to the belt length. Kalau untuk dua pulley yang berbeza, then you need to apply this formula. Kalau you tengok pada beta 1 ni, angle of beta 1, angle dia adalah less than 180 degree. Whereas untuk beta 2 ni, dia lebih 180 because of this one, this small angle over here. This small angle is alpha. This small angle actually is alpha. Same apply to others. So alpha, sudut alpha tu you boleh dapatkan daripada formula yang ini. Okay, R2 minus R1 over center to center distance of the pulley. Macam mana nak dapatkan sin theta, sin alpha tu? So from this diagram, so let's say this is C, center to center, and then this is R1, and then this is R2. And then saya buatkan satu belt from this point, center the touching surface, and then this is the touching surface of the bigger pulley. So this is by right, this is a C actually, and then alpha is actually the angle from the horizontal to the line parallel to the belt. So I draw another line from the center to this one. Okay? So you will get actually this length is actually R2 minus R1. This length is actually R2 minus R1, because from here to here is R2. So the balance over here is actually R2 minus R1. And then since this is 90 degree angle, so you will have a sin theta over here, sin theta is equal to R2 minus R1. This is the one. over C. Okay? So this is where we got the theta to explain from where the alpha is. Right. Just now we call it, okay, this is lambat lah pula. Okay, this is open belt. Open belt system. Open belt lah While this is cross belt. This is cross belt. Kalau open belt tadi, this one is R2 minus R1 squared divided by C. But here, in cross belt, R2 plus R1 squared plus C. Okay? Because the belt is a bit longer. Then, this is the belt length for cross belt. Okay. Belt drive arrangement. Dia ada open belt, cross belt, serpentine, belt drive. Nanti boleh dapat lah with either pulley apa, mule. Nanti tengok balik lah yang ni, apa dia. Right? This is another arrangement of belt. Dia dah jadi compound belting yang ni. Tak dia bersambung-sambung kan, macam yang tadi on the first picture that we see on the ball mill just now. This is kalau you refer pada bottom right, this is the pulley, and then with a different sizing, different diameter. 1, 3, 2, 3, and 4. 4 groove. This is a 4 groove pulley. So simple je kan. Kalau dia nak change the speed, so dia akan tukar pergi bigger one, and then this one will be offset over here untuk make sure that the belt is within in a good alignment lah. Otherwise belt tu akan twist nanti. Okay, this is another example lah of the application lah untuk ubah dia punya input and output. Let's say this is input and output, let's say kan, or multiple output or whatever kan. Dia punya arrangement lah. Kalau pakai flat belt is very difficult. Kalau pakai round belt, then it's easy. Nak buat benda ni lah. Kalau flat belt, you punya belt nanti akan twisted. So round belt is easier lah. Belt drive kinematics. Velocity ratio. Belt speed. Velocity ratio. Lebih kurang sama macam gear. Kalau you tengok, velocity ratio is omega 2 over omega 1, and then R1 over R2. This is the velocity ratio of the belt. Untuk yang T ni is actually the thickness of the belt. Thickness of the belt. Kalau let's say there is a problem where they mention dia punya thickness of the belt, then the velocity ratio need to apply this equation lah. Tambahkan dengan dia punya thickness of the belt. Belt speed. Belt speed ini adalah formula yang basic lah. V equal to R omega, because this one is actually radius lah. V1 B is equal to R2 omega 2 and so on lah. Kalau tak ada slip, dia akan dapat pakai ni. So this is the basic formula. This is the drive pulley yang connect to the motor. Rotate at 100 RPM. Rotate ada, terbalik pula. Okay. Dia dah bagi dah dia punya rotation in this direction. Rotate in this direction. 100 RPM. So when the pulley rotate at 100 RPM, dia masih capable untuk the coefficient of friction masih okay untuk dia grip between pulley and belt. So when the motor increase the speed to 300 or 400, I don't know, probably dia akan berlaku sedikit slippages. Maksudnya most probably you punya pulley akan running at 300 round per minute, whereas you punya belt akan running at 290, let's say. So dia ada reduce sikit lah. So tu maksudnya slippage. So dia tak properly match dengan dia punya surface. If let's say dia bagi percentage of slip at drive pulley is G1, and then G2 is the percentage of slip at driven pulley. You have to remember that omega 2 over omega 1, this is the real velocity ratio. Real velocity ratio. Whereas R1 over R2 is the theoretical. Is the theoretical. So what you need to do is, since this is the theoretical and then omega is the real velocity ratio, so you need to times, darabkanlah dengan berapa percentage slip ni tadi. Kalau let's say percentage slip untuk pulley 1 is 10%, and then pulley 2 is 10%. So kat sini you dah ada 10 and 10 kan. So it's actually 1 minus 0.2. 1 minus 0.2 times R1 over R2. So this is the ratio lah. So at the end dia akan dapat the velocity ratio is actually equal to R1 over R2 times 0.8. Kalau ada berlaku slip lah, slip percentage. Okay. Belt creep. Ni yang tadi kita cakap creep ni kan. So creep tu yang kalau tengok dia akan berlaku belt extend and contract. Bila dia lalu dekat pulley tu, so belt tu akan ada yang expand dan akan ada yang contract. Dia mengembang, mengecut, mengembang, mengecut. So this is dipanggil creep lah. So idea dia kalau ada creep tu, and then you know that the stress of the belt in the tight side and the slack side is this one. So and then you tahu dia punya Young modulus of the belt. So you boleh dapatkan dia punya ratio. Again, this is the actual ratio. This is the theoretical. You kena darabkan dengan effect of creep. Effect of creep. So sekarang ni senang lah, tak payah nak hafal formula kan. Formula dah ada depan mata kan. So boleh cuma you kena alert lah where is nak apply kan formula ni. Okay, belt tension. Sama macam basikal tadi. This is the input. Let's say the rotation is in this direction. You nak bawa puli yang besar ni, you nak bawa puli yang besar. Of course, dia akan jadi tight side on the upper side lah kan. And then dia akan agak kendur pada sebelah bawah. So we call it, kalau yang agak kendur ni, we panggil dia TS, and then on the tight side is TT. Okay, tight side TT, and then this one is TS. So by right dia akan menjadi, this is straight line. Bila sampai yang bawah dia akan a bit macam ni lah. Yang atas dia akan straight. Yang atas dia akan straight. Nak lukis straight pun tak boleh straight. Yang atas dia akan straight. Compare to yang bawah ni akan ada kendur. Okay, that is the tight side and slack side of the belt. When we talk about moment, talk of belt, because this is the power transmission, you know that torque or moment is actually force times R. Force times R, where force is the resultant force. In this case, you know that dalam satu belt dia ada TT and TS. And so you tahu that dia ada TT and TS, tight side and slack side. So bila nak cari moment, so you know that moment is equal to F times R, but then the force is a force resultant. Force resultant means the tension, tension of the belt itself. Then tension on the tight side minus tension on the slack side didarabkan dengan di puli radius, you boleh dapat dia punya torque ataupun moment yang dia boleh transfer from the pulley lah. So that is the torque. That is the torque. How to get the torque? You have to get the resultant tension, resultant force. Okay. Whereas for power, you know that belt are having a certain velocity. Belt is moving in a certain velocity. At each point, dia akan ada velocity dia kan. Okay. So power transfer kita boleh derive daripada formula ni. Still the resultant tension times dengan velocity, you akan dapat power of the torque. Okay. This is how to measure a belt tension. Tadi dalam video pun ada tunjuk benda ni, cuma tak ada suara tadi kan? Ada suara tak tadi?
Tak ada doktor.
Yang awal-awal tadi
Okay.
tak ada.
Tak ada kan? Tak apalah. Saya pun tak tahu macam mana nak keluarkan suara tadi. Saya dah buka volume pun tak boleh juga. Okay, this is the equipment untuk measure belt tension. Kenal je lah dulu equipment ni. How to use that one, kalau ada masa nanti kerja bolehlah pakai kan. 1, 2 dan 3 belt. Ada 3 belt. So all the 3 belt must be within the same tension. So biasanya apa yang kita buat, biasanya apa yang industry pieces of belt, dia akan install with a belt with the same brand, belt with the same manufacturing batch. Sebabnya adalah different belt will elongate differently, kan? So biasanya pasang belt baru yang diperbuat daripada company yang sama dan brand yang sama lah. Kalau kita mix up together, so nanti once you tension, you will find that one belt is tension enough, another one belum tension pun lagi, dia kendur. So it will reflect to the top performance later, to the power transmitted later. Okay, this is the belt alignment. This is the correct one actually, must be properly aligned. There is a tools over here with a laser measurement. This is the receiver to ensure that pulley A and pulley B are within a straight line. And then bottom left, bottom right, we can see that this is another equipment of the laser pointer to see the straight line. The same applied to here. Nampak straight punya line tu. Okay. This is I just want to show you the how to use the velocity measurement or RPM measurement. Over here, this is the contactless tachometer, where you can measure, where you can point at the shaft over here. So kita boleh nampak lah nanti dia punya speed berapa. Okay, you can letakkan reflector over here. This is the contact. Yang tadi contactless kan, yang ni contact. So you can put at the shaft over here, nanti dia akan measure lah berapa RPM and so on. Whereas ini jenis yang roda punya, so dia basically sama je macam yang ini, cuma dia punya application dia yang ni untuk surface, dan dia boleh convert pergi ke RPM lah. So this is the instrument ataupun device untuk measure velocity and RPM. Kita bercerita berkenaan dengan flat belt. Sebenarnya formula ni ada dia punya derivation dia, tapi kalau you nak tahu, you boleh baca dekat module lah macam mana dia derive this formula. So apa yang penting kat sini, apa yang penting di sini adalah kalau you bercerita berkenaan dengan flat belt, flat belt, so dia TT is equal to TS E, where this is the coefficient of friction, and then this is the angle of contact. Angle of contact. Whereas kalau untuk V belt, you have to E sin alpha divided by 2, where alpha is actually this one, the groove angle of belt. So ada buku yang dia bagi tahu, kena ingat ada buku yang cakap dia ni alpha tau, and then ada buku yang bagi tahu dia ni adalah beta. Tapi you kena ingat lah, you kena alert lah, you kena alert that this is actually untuk groove angle. Groove angle mean pulley tu dia ada longkang, so the longkang is how much dia punya angle. So dia ambil separuh daripada ni, divided by 2. That one. So this is the important formula dengan yang ni lah untuk menyelesaikan permasalahan berkenaan dengan belting system. Okay. Kalau you tengok sini, this is the coefficient of static friction, and then this is the angle of contact surfaces. Yeah. When we go to V belt over here, this application should be applied, and then we have to remember that this alpha over here is the groove angle, and then this is the angle of contact. Yeah. So that is the thing lah. So, but then this value, even though like say they are giving you the value of alpha is actually 60 degree. Sorry, not this one. Like say they are giving you beta, this one. Yeah? The angle of contact is 120, let's say 120 degree. So here you have to convert it into radian. You have to convert into radian. Sebab kalau dalam degree tak boleh lah kan. But this is kalau yang ni yes, this is in degree. This is in degree. Tapi yang atas ni in radian. Okay. Pukul apa? Pukul 5. Pukul 5:10. Okay, any question so far?
Tiada doktor.
No, sir.
Tak ada. Okay, good. Tak ada. Kalau tak ada, move to the next slide. Next slide adalah example. Next slide lagi adalah example juga. Okay, this is a possible question and answers. Boleh jawab lah dia apa beza open belt dengan cross belt. So, kalau rajin boleh baca, tengok kat internet dah boleh dapat lah jawapan. This is a picture of a material handling belt. So it is a flat belt actually, tapi dia letak this pocket, letak this is a pocket bucket over here, and then dia letak side wall over here. So yang ni side wall dia dah tanggal, so gum dia dekat sini dah tanggal. So by right dia adalah flat belt lah yang digunakan untuk mengangkat pasir ataupun apa pergi ke atas lah. So this is the pocket belt yang cut from bottom to top. Okay. So that's all.